All right. How's it going out there in remote land? Going to chat about the rock cycle today, right? We've been talking about igneous rocks. Now we just want to give you the bigger picture, take a little step back, look and see how all rocks go through their cycles, and then we'll pick up with sedimentary afterwards. Okay? Let's do it. Quick little funny film for you.
You know, Globey, here on Earth we have three basic types of rocks: igneous, sedimentary, and metamorphic rocks. Scientists classify these rocks by the way they were made. Igneous rocks are formed when lava from a volcano cools and hardens. Igneous rocks are also formed when magma cools below Earth's surface. Sedimentary rocks are formed when the elements wear rocks down into tiny particles of dust, sand, and soil. Wind and water help move these particles around and deposit them into layers. As time passes, these layers are cemented together and harden into new rocks. Metamorphic rocks form when sedimentary or igneous rocks change after being exposed to extreme heat or pressure without melting. As conditions on Earth change, rocks may change from one type to another. Sedimentary rocks can change into metamorphic rocks, or, if they melt, into igneous rocks. Igneous rocks can change into sedimentary or metamorphic rocks, and metamorphic rocks can change into sedimentary or igneous rocks. Scientists call these changes the rock cycle.
All right, so how do we define the rock cycle? Quick little read there, hit pause, make sure you skim that through. Okay. There's your official definition, right? A never-ending cycle that shows the different rock types and how they change from one into the other. That big word there, they're all interrelated. Rocks, of course, aren't living things, but the rock cycle is pretty complex and constantly evolving. Okay? The driving forces of the rock cycle, well, here you have it. Energy from the Earth's interior, right? That heat escaping from Earth's interior, driving plate tectonics. Sun's energy, of course, right? Evaporation, precipitation results in certain sedimentary rocks. Gravity, of course, right? As rocks break apart from weathering and erosion, gravity brings them down, starts to pile them up. And these forces, of course, create the following processes. And all of these processes are the vocabulary inside of the cycle there. Compaction, weathering, erosion, melting, heat, pressure, uplift, etc. Okay, and they're all nicely labeled on this diagram, which is, of course, in your reference tables as well. All right, how are rocks different from one another? Well, based on their origin, to simply put, right, we've been studying igneous. We know that the word igneous means born of fire, so they come from either lava or magma, and they cool and solidify, and some grow crystals, as you know. Okay, that's what's going on here. Nice little picture of the diagram there. So here's the magma coming up. If it cools underground, we said they were intrusive. If it exits the earth, they're extrusive. Those rocks break down over time, right? Weathering and erosion, they get deposited, can turn into sedimentary rocks close to the earth's surface. And then if they get buried deeply, they'll undergo a metamorphism. Okay? So how do we define a rock? Well, rocks, of course, are composed of one or more minerals. If it's one mineral, they say monomineralic. If it's more than one, they say polymineralic. Okay? And there you have it. Mono for the one, right? Example, rock salt is mostly halite. It's not pure halite because then it would just be the mineral. But for the most part, it's only halite. Limestone is only a calcite, right? There are some impurities in there, but that's what limestone is. And then there's the polymineralic rocks, right? Of those gorgeous speckles there made of more than one mineral. Like granite that we looked at in the lab. You get quartz, feldspar. There's some biotite in there. Plagioclase feldspar. It's many different minerals combined there. Igneous rocks, of course, start from the melt, right? Down here, the magma, and they solidify. And there's your gorgeous picture of magma, right? From the cooling and solidification of hot, melted, molten rock. And here you can see many different types of igneous rocks. Okay? The minerals crystallize as they cool, right? Magma is when it's below the surface, that molten material, and lava when it's at the surface. All right. Sedimentary rocks are kind of the next step, if you will, right? There's going to be a breakdown there. So from igneous, you can weather them into sediments, which ultimately turn into sedimentary rock. And they often make these gorgeous layers, as you'll see when we take a closer look at sedimentary rocks, formed by the compaction and cementation of layers of sediment. And there's some examples of sedimentary rocks for you there. Okay. Sandstone, maybe you've heard of. Arkose is another type of sandstone. Limestone, I'm sure you've heard of that one, or conglomerate. Shale, lots of beautiful sedimentary rocks. They call them the soft rocks because they're generally not as durable, not as tough as igneous or metamorphic, but absolutely gorgeous. Plus, these are the rocks that can contain fossils. Very exciting. Okay. And then you get metamorphic rock. Well, after either the igneous is formed or sedimentary formed, they can change. And as you can see, you follow here, they can change into metamorphic rocks. Right? Igneous, you put heat and pressure on them, will metamorphose, as well as sedimentary, if you put heat and pressure on them, will metamorphose. And of course, they form from pre-existing rocks, right? They get changed as a result of heat and pressure. We call it recrystallization. There is no new melting, but the minerals get a second chance to grow and recrystallize. And you get these gorgeous banding in some of them. Others become very shiny because when they recrystallize, the crystals grow bigger and can reflect more light. So very, very pretty rocks. Many of them, of course, very durable as well because they've really been squeezed together. Okay. So here's a chart. Give it your best shot. Okay, see if you can figure out what goes in each position without referring to your notes as much as possible. And of course, we'll go through all that back in the meet. And then, of course, there's some summary questions that follow as well. All right, so do your best. See you there.